Would you like to learn how to build spherical structures like this one? Let me show you how. The first step is to calculate distances in 3 dimensions. We do this using the Pythagoras Theorem. Here we see that the change in x, creeper, go away, stop harassing me, is 4. And the change in y is 3, and it's a 90-degree angle. Therefore, the blue diagonal is 3 is the square root of 3 squared plus 4 squared, square root of 25, 5. But of course, what we care about is 3 dimensions. So how do we do that? Let's look here. The long line here is length 12. The blue line is still length 5, and the angle between them is also 90 degrees. So the black line is 5 squared plus 12 squared as the square root of that, which happens to be 13. So it's the change in x squared, plus the change in y squared, plus the change in z squared, square root of all that. So in practical terms, if we know that we have a certain x, if we want to do, let's say, a sphere or a dome of radius 5, and we know that from a certain point we chose we have a certain x and the z, then the y has to be equal to the square root of r squared minus x squared minus z squared. So now let's start building. When we have our initial spot, let's say we'll make our center here, this red spot, and this is 0, 0, 0. 1, 2, 3, 4, 5. This is going to be our top spot. Now let's see what the next spot is going to be. Let's say 1 here, 0 here. Oops, we can't really do 0.9 blocks. So let's do a floor function. And here it tells us that at 1, 0, we have to be the height of 4 blocks, same as 2, 0, 3, 0. And because spheres are symmetrical, this is going to be in every one of the cardinal directions. So we can do it here. And we can do the same thing here. I'm not going to fill the entire dome up. This we can always add or delete blocks later after we have the shell for it. Okay, because we can switch between x and z whenever it's convenient. Now if z is 1, then and x is, well, no, if z actually if x is 1, 2, or 3, we said, and z is 0, it's 4. Now if z is 1 and x is 0, of course it's also going to be 4. But if it's 1, it's 4. If it's 2, it's 4. If it's 3, it's 3. So now let's do all the 1, 1 and 1, 2s, and they're also 4. 1, 1, 1, 2, 2, 1 because it's symmetrical. 1, 1, 2, 1, 1, 2. 1, 1, 2, 1, 1, 2. 1, 1, 2, 1. Oops, 1, 2. Okay, now what happens if z is 0 and x is 4? Then we have a height of 3. So let's do that part. I think it's here. No, my mistake. Well, it would be easier to do it here probably. 1, 2, 3. And here we also need it to be at height 3, and we need to attach it to something. So let's fill this one and this one, this one and this one. Oops, did one too many. This one and this one. The next case would be 4, 5, and 0. In this case, of course, y is going to be 0. Depending on what we want to do, we could leave this space open, but that would look like a hole in the sphere, and for now we want to do a complete sphere. So let's fill it up. Oops. Here. Here, of course, it's already filled up. Okay, good. It's what we need on all sides. Now, let's look at 4, 1. And at 4, 1, we're going to be at height 2. Oops. Wait. No, that was 3, 1. We want 4, 1. And there are, because it's plus minus 4 and plus minus 1, we have 4 of them, but then we can switch x and z, so we actually have 8 of them. That's one advantage to spheres, they're symmetrical, and because they're symmetrical, every calculation you do is applicable either 4 times or 8 times. Okay, now let's look at 4, 3. 4, 3 is 0, we don't have to do anything. And 4, 4, of course, is going to be a square root of a negative number. So again, we don't do anything. It's outside the dome. Now let's look at 3, 3. 3, 3 is also going to be height 2. So let's see. This is 0, 0, 1, 1. Okay, let's do 2, 2 first. If we have 2, 2 here, then it's 4. Or this level. 1, 2, 3, 4. And we said that if we have 3, 3, then it's 2. Yes, this is the correct location. Oops. Okay, so now we have all the 3, 3 spots. We are still missing the 3, 1 and 3, 2. So 3, 1 is 3, and 3, 2 is also 3. One, two, three. Oops. Okay, it's sometimes easy to get confused. You might find it easier if you press F3 and then you have the coordinates. Or if you use color coding for the blocks, these don't have to be the final blocks, they can just be the blocks we use while we're working on this. Oops. Go away, block, I don't want you there. Okay, now we have the 3, 1, the 3, 2, the 3, 3. So we have all the 3 by 3s. What we're missing now is the 1, 2, 3, 4, 0, 1, 2. 4, 2. 4, 2 is going to give us a height of 2. Okay, and of course we're going to have 8 of them because of the symmetry. Okay, and our sphere is ready. Of course, it isn't looking as spherical because, oh no, one part missing. By the way, it's very useful to be able to fly up and see if it's symmetrical or not. That's a good sanity check. Our sphere is now ready. Of course, it isn't looking very spherical. The reason is that it's only radius 5. The higher the radius, the more spherical it's going to look.